afternoon, ladies and gentlemen. My name is Kyle Kester, and I work for KK Industrial Hygiene Services. Today, we will be talking about Western Tool and Machining. So this is a machine shop out in Western Kentucky that we have been called in to do a sample for. We will be sampling acetone for them, actually. So this is basically the rundown of what we will be doing today. And then this is actually going to be the post presentation as well. So this is something that's already happened. We're just giving a run through of what we've done and how we've done it. So the environment that we will be working in, obviously it is Western Tool and Machine Shop. They specialize in machining specialized tools for various different projects. So I mean, it can be anything for specialized wrenches for pipe fitters, to specialized parts for different machines such as a bowling machine, or anything like that that just needs a weird tool. So it's a very specialized piece of work. There's not a whole lot of them that do as much as they do as far as specialized work goes. The process will include employees cleaning the machines that they use to create the parts that they need. So there's a bunch of grime, bunch of oil, bunch of dust, all kinds of different stuff that they will be cleaning off today. It's a 7,000 square foot facility, so there's a lot of machines and a lot of parts to clean. So we're expecting this to take several hours. We will be using all the proper lockout tagout systems. Every machine and individual moving part will be locked out prior to the cleaning. This is something that Western Tool and Machine utilizes on any shutdown. There will be no power going to any of the machines, so the guys that are cleaning it will be safe. They have brought us in to ensure that the employees are not facing adverse health effects. So we will be sampling for acetone. Like I said, that's what we're focusing on today. That's the chemical that they are using to clean these machines. We are estimating this task will take about 8 hours, although we've allowed 12 hours of downtime for the shop. This is just to make sure that we do not find anything broken, anything that requires extra cleaning or maintenance work that needs to be done on it. It's that little safety net that we put in place in case it does go past 8 hours. I will be present for all 8 hours of work. I want to make sure that I'm taking thorough notes over the tests that they're doing, how they're doing it, and this is just to ensure the accuracy of the information that we're giving. We also want to make sure that they're not messing with our pumps. Our pumps do have a locking system on it, so I will be the only one to change the flow rate of them, and any other settings that they might change, they cannot do it due to the locking systems. So the personnel, we have 4 maintenance workers. They are all males, from 27 to 41 that's our range of employees' age. These guys are very inexperienced as well. The 41-year-old has been doing this since he was 18 years old. The younger guys, they always look up to the older guys. It's a very good system to have in place as far as mentorship and stuff like that. So it seems to me like everybody is pretty well trained on what they're doing. We are not expecting any kind of mishaps. Everybody knows the test that they're doing. They have already had their THAs. So everything should go as planned. So each employee has already passed their yearly physicals, along with their yearly respiratory fit test. That involves the questionnaires and the physical fit testing. Now, Western Tool and Machine requires them to use quantitative fit testing, so the data given we will be looking over before they go in to ensure that they have the proper fit. The supervisor, the maintenance worker supervisor will be there, although he will not be on the floor. They have a maintenance worker area upstairs with a glass window overlooking the floor, so that's where he will be staying. In the case of him needing to come out and do anything or correct something, he will be required to put on his respirator to come down. And that is just for his safety, and he is aware of this. So the process. The crews will begin work on the east side of the shop, and then they will clean each individual machine, part, anything that moves, anything that's got dust and grime on it, just to ensure that we are doing proper maintenance on them, and we are not going to cause a failure later on. We want to make sure that everything is properly maintained. So the crew sizes. So like I said, we have 4 individuals doing the cleans. They will actually be paired up in pairs of 2. The reason they do this, not only in case there's a man down scenario, which hopefully will not happen today, they do it that case along with job rotation as well. That way, they're not overly exposed in direct vapors of the acetone. They will be using acetone soaked rags to wipe down the machines, along with the acetone soaked rags. They will also be using spray bottles with acetone in them for any kind of really strong dirt and grime, so that acetone can soak on that dirt and grime in order to try to break that loose if they cannot get it with their hands. Like I said, the crews will rotate employees who are doing the direct cleanings. This is just to ensure that no one's overly exposed. And this is something, like I said, that Western Tool and Machine has already put in place. So this is not something that we are telling them to do. This is just based off their standard operating procedures on how to clean these things. So all other standardized operating procedures will be followed during this time. So a couple of those being hot work while there is cleanings or maintenance going on. There will be no hot work allowed unless the area is completely cleared of acetone. The reason for that being is acetone is a flammable substance. We do not want nothing to ignite today. So we, along with them, that's something that they've said once again, but we are here to enforce that rule as well, and something that we agreed to do for them. So the procedure itself. So the process is going to start with properly locking out and tagging out all the machines. At this time, we are not going to count that for the pump samples. Reason being for that, that's just like any daily task for them. They lock out machines pretty often, so they know what they're doing with it. We just don't feel like it's necessary to start that pump yet, because that's not when the actual physical test starts. So upon the proper lockout and tag out system that they have in place and all the machines are locked out, that is when the maintenance workers will get suited up and get ready to actually begin the work. So some of the PPE that they are required to wear is going to be a full face respirator and then rubber gloves. They have chosen to wear the full face respirator because not only is acetone a respiratory hazard, it is also an eye irritant hazard. So with the full face respirator, they will actually mitigate both of those hazards. So that is starting off well. The rubber gloves, not a huge thing, but you don't really want acetone getting into a cut that you had on your hand. These gloves are cut rated of A3, so it's not the most resistance, but there is some resistance there. After all appropriate PPE has been put in place and they're all suited up and ready to go, that is when they will actually begin the work of cleaning the machines. So at that time is when I will come in and put the pumps on them, place their media glasses, and place their intakes. So like I said earlier, we will be using the AirCheck Essentials. This is a pretty easy pump to use, but once again, it's got a locking system on it to where once I put it on and lock it, they will not be able to mess with it. So at that point, I will be kind of hands-off, just observing the processes in order to make any kind of recommendation that I feel is necessary. I've also brought a couple different instruments with me today to check a couple different things, such as the indoor air quality of the place and VelociCalc, which is made by TSI to check the velocity of the air. We are doing this to check the ventilation of the building, which currently they have no source of ventilation, so it's only naturally ventilated. So that'll be something that we look at the end as well. After we put on all the pumps and everything's beginning to work, that is when the process will begin, the cleaning process will begin. So like I said, they'll be using acetone soaked rags and spray bottles to clean these materials. It'll be degreasing, so any kind of grease buildup or grime buildup, they will be taking that out. Hopefully it's not too bad. This is something I do every 6 months, so we should expect a pretty easy process and easy going. After the cleanings are completed, I will remove the samples, properly store them into bags, and ship them to the lab. We do not have our own lab service at KK Industrial Hygiene Services. We use a third-party lab in Chicago, Illinois. The reason we do this is so we can ensure that we have a third-party eye on it, make sure everything looks good. I will also send them the paperwork to see how that we collected these samples. So, hazards associated with acetone. Like I said, we already kind of covered this a little bit, but the biggest one is a respiratory hazard. You don't really want this in people's lungs. The other one is an eye irritant. So that is why we're using the full-face respirators with the proper filters on it. This will mitigate not only the respiratory hazard, but it will also mitigate the eye irritation hazard. Along with those two, it could sting pretty bad if you got into a little cut or something, so we have them in gloves. And then it's also flammable, and that is why we're using the zero tolerance for hot work during these times. So those should be mitigated at the time of this work. So these hazards are not only mitigated through the use of PPE, but we are also using the administrative control of job rotation to kind of lower those levels just like they normally would. So everything that they're doing today or have done, this was all their natural procedure. It's their standing operating procedures which they go off of, so we're not expecting to see too much of an issue here. So the applicable standards that apply to acetone, so you have your different exposure limits. So the NIOSH exposure limit, which is a REL, it is 250 ppm for the 8-hour time-weighted average. So that's going to be the lowest standard that we look at today for this. The OSHA PEL is 1000 ppm for an 8-hour time-weighted average. The ACGIH TLV is 750 ppm for the 8-hour time-weighted average. ACGIH STEL is 1000 ppm for a 15-minute exposure limit. So the biggest difference with these, is the 8-hour time-weighted average and then the 15-minute exposure limit. So the 15-minute exposure limit, that's going to be the most you can be exposed to for 15 minutes. That's going to be short exposures. We're not really worried about this necessarily today since we've got such a long duration of cleanings to do. So we will be looking at the other standards applicable to acetone today. So we also have IDOH conditions. That is 2,500 ppm, and that's when it would be considered IDOH. Hopefully we don't ever have to worry about this here. They're not really using enough acetone to have that high of levels. So it's not something we really have to worry about, but that is an applicable standard that applies to acetone as well. So our compliance program, our company and clients have agreed to go above and beyond what is expected of the governing body, which is OSHA. So, like I said previously, their permissible exposure limit is set at 1,000 ppm for an 8-hour time weighted average, and we have decided to go above and beyond that, not only to protect their employees, but also so they can be seen as a model safety program, which is something that they have set out to do anyway. So we will be following the NIOSH REL, and that's going to be 250 ppm for an 8-hour time weighted average. Like I said, that is the standard that we are going to be going off of. That is above and beyond what OSHA sets out for us, but at that same time, we are actually going to set a goal to mitigate the exposure levels to below 225 ppm. So we're even above that, or below that 250 ppm mark for 8-hour time weighted average. And like I said earlier, that is something that not only we try to do at KK Industrial Hygiene Services, but that is something that we have agreed upon between KK Industrial Hygiene Services and Western Tool and Machine. So it's really a goal that we've set. Western Tool and Machine has had a goal of being a VPP Energy Star, so they want to go above and beyond everything else. We have chose this standard due to it being the lowest limit. Along with that, OSHA has also openly admitted that their acetone standard is probably behind the times. Now that's something that us at KK Industrial Hygiene Services look at very strongly, and that's also why we have recommended that they use a NIOSH REL as their standard to go off of. So the sampling method, we will be using the NIOSH method 1300 to sample the acetone today. The equipment that we will be using is we're going to use 4 SKC AirCheck Essential Pumps. These are all up to date as far as the technology that's out there. It's one of the newer pumps that's out there. Along with that, we have calibration records for them. We will also calibrate them before the use, and then we will calibrate it after the use. So before and after the sample is done, we will be calibrating them as well. We have set the sampling speed at 0.5 liters per minute. This is what the method 1300 sets out for us to use. It's the recommended flow rate, so that is what we will be going off of. The volume of air we are looking to collect is about 3 liters. So that is also based off of that method 1300 that NIOSH puts out for us. The limit of detection for acetone is 14.1 micrograms. The sample media that we will be using is also set out in the NIOSH method 1300. This will be a coconut shell charcoal. So basically there's 2 stages to this. The first stage is going to be 100 micrograms of the coconut shell charcoal, and then the back stage will be 50 micrograms of coconut shell charcoal. And then this will be within a 7 centimeter tube by 6 centimeter tube. So the length of it's 7 centimeters and it's 6 centimeters wide. It's just your typical media tube or media holder. Our 2 parts of the coconut shell charcoal will be separated by a 2 milligram urethane foam plug, and this will also help catch any other things that are going through there. Excuse me. We will also be using 5 field blanks. We are doing this to ensure that we are getting accuracy. In the NIOSH method 1300, it recommends 2 to 10, so we feel that 5 is in the middle of that, so we should be good there. We will also be sampling for 8 hours, which has already been set out, but we just want to again go over that again to make sure everybody's aware of that. Upon receipt of the sampling, or upon finishing the sampling, we will then take our samples and our media and ship them off to our lab out in Chicago to get our analysis done. So the results have came back. The lab analyzed the media by breaking it down into the different parts. So we have our parts from the coconut shell charcoal, and then we also have separated that from our acetone. So they've been able to tell how much acetone is actually in the air at the time and what our guys are exposed to. So they have determined that there is a concentration of 557 ppm, or parts per million, of acetone in the air when they are doing these processes, which unfortunately is much greater than what we have set our goal out previously. So we will be looking at doing a couple different things for Western Tool Machine to help them really mitigate that exposure level. That is much greater also than the NIOSH REL, which is the standard that we use, so we have some mitigating to do. Although it is lower than the OSHA PEL, which is the regulatory body, we are not looking to just comply with OSHA. We want to make sure these guys have the safest environment that they can work in, so we've really used that to drive us forward as far as making recommendations and what we can do for them to ensure that this is the safest environment that they can possibly work in. So, some potential corrective actions that we have talked about at KK Industrial Hygiene. So, an engineering control that we have decided would be ample or capable of mitigating this hazard the most would be a forced air ventilation system. Now, a forced air uses fans to bring in air and then push out air. So we have looked at the building blueprints and determined which place would be best for ventilation systems. Now, with that being said, I mentioned earlier that I did bring a couple other tools with me when they were doing the processes. I did pull out my VelociCalc to look at that. Those readings were very poor. It looked like there was only natural ventilation in there and they didn't have any other kind of ventilation system. So that'll be something that we at KK Industrial Hygiene have looked really into. So by using the blueprints, we have been able to establish where would be good places to put ventilation systems in to help blow that air through there. The next control or corrective action that we have brought into consideration is a better job rotation program. So although they are already implementing the job rotation with at Western Tool Machine, we have determined that since they have two crews with two people each and one of them is there at all times, we have come up with the idea of implementing a third crew. That way a crew can rotate in and out at all times. That way their exposure limit is then dropping as they are not exposed to it. They can go sit in the workroom or the maintenance room above with the supervisor at that point. The reason this is even though that they are job rotating as far as who's directly working with the vapor, this will actually allow them time away from the vapor. So that would be a very good thing to implement as well. Last thing that we can use as a corrective action is the full face respirators. Now granted, that is currently what they are using for this, so they were doing this correctly, but that's not really helping as far as mitigating the hazard. That's just lowering the exposure limit that they are directly exposed to. So if anybody else walks in that shop while they're doing this, they are automatically exposed to the 557 ppm of acetone. So that's not something that we are trying to lean forward. It's something that we've also discussed at KK Industrial Hygiene Services. So our final recommendation that we made for Western Tool and Machine Shop is installing a proper ventilation system for the tool shop. Now, like we discussed with them, this is more expensive as far as initial costs. But that being said, we believe that it will truly mitigate that hazard the most. We believe that we can drop that 557 ppm of an 8-hour time weighted average, down to the 225 ppm for an 8-hour time weighted average mark that we have set out prior to actually doing the sampling. So that is what we will be recommending today. It wouldn't hurt to add another crew like to do the job rotation, or ensure that they're still wearing their full face respirators. Now that being said, we want to come out after you all have installed after they've installed the forced air ventilation system. We want to come back out and redo this test, along with do an indoor air quality test and test the velocity of the air inside, to really test to make sure that they have the proper thing that they need. So that'll be something else that we recommend as well, is doing a retest once everything is put in place. And it's 6 months down the road, I understand, but it would be best if we could get the new level of exposure that your guys are exposed to. And that is all we have for you today. Thank you all very much.